Space, the final frontier. These are the journeys of the starship Whistler.
And if I told you once, I ain't gonna tell you twice. Salute all my real ones. Look, bro, we got Brian Greene. What was there before the Big Bang? I really want to know this. I'm gonna keep it super short. Like button, subscribe button, notification bell, press those. Let's go.
The Big Bang explains the evolution of the universe from a starting density and temperature that is currently well beyond humanity's capability to replicate. Thus, the most extreme conditions and earliest times of the universe are speculative, and any explanation for what caused the Big Bang should be taken with a grain of salt. Nevertheless, that shouldn't prevent us asking questions like, what was there before the Big Bang?
However, another answer is that the very question may not make as much sense as the words seem to suggest. We know how to parse that sentence. We know what it means to talk about the moment before the Big Bang because we fully understand the meaning of that kind of sentence. But it could be that when it comes to the Big Bang, the sentence actually doesn't mean anything. It could be that the Big Bang was the place where time itself started. Talk about 1 billion years ago or 10 billion years ago, but if you go to 13.8 billion years ago, the Big Bang, that may be where time started. And you can't go further back in time than the very origin of time itself.
To understand how the universe came to be, scientists...
I get what he's saying, but it's like, all right, cool. A clock measures time, right? Unless you're telling me, so the way that I'm thinking about it is, all right, I can't go past time if time doesn't exist. But what if I'm in a bubble and I have a mechanical watch, and instead of me going back 13 billion years, what happens if by my watch, which is a physical representation of time, right? It's not physically time. But what if on my watch I say, yo, you know what? I'm gonna go back 20 billion years. What would existence, reality of look like 20 billion years ago, which is 6-7 billion years before the Big Bang? I know what he's saying, but I still think what I'm saying makes sense.
Combine mathematical models and observations and develop workable theories which explain the evolution of the cosmos. The Big Bang Theory, which is built upon the equations of classical general relativity, indicates a singularity at the origin of cosmic time. However,
okay, so then the question is, right, because he's saying you can't go past, I'm still on that, you can't go further back than the creation of time. And there was a singularity. How long did that singularity exist for? What created that singularity? And how far back does it go? Yeah.
However, the physical theories of general relativity and quantum mechanics as currently realized are not applicable before the Planck epoch, which is the earliest period in time in the history of the universe, and correcting this would require the development of a correct treatment of quantum gravity. Certain quantum gravity treatments imply that time itself could be an emergent property, which leads some physicists to conclude that time did not exist before the Big Bang, while others are open to the possibility of time preceding the Big Bang.
There's nothing wrong before, we just don't have any data. I don't mind going into negative time. I have no problem with that. I don't mind resetting where the 0 point is. Time is just, where you put the 0 is arbitrary, as it continues to be this day with calendars. Right. And so the starting point is just where you want to put it. And so right now, a pretty good starting point is the Big Bang. We don't know how to put it earlier than that. But if the day comes where a whole new kind of understanding of the universe reveals to us before that, I don't have any problems pushing the 0 point back or just counting into negative years.
The idea that I think most physicists or cosmologists buy into at the moment is that gravity can have two manifestations. The usual form of gravity is the attractive version. You drop something toward the Earth and it moves downward because the Earth and the object pull on each other. That's the ordinary gravity that we experience every day of our lives. But Einstein's equations actually allow gravity to also be repulsive. it can push outward as opposed to just pulling inward. And this is something that we have never experienced because the gravity created by a rocky object like the Earth is always the attractive variety. The gravity created by the sun, again, a compact object, is always the attractive variety. But Einstein's math shows that if you don't have a rocky object that's isolated in space, but rather energy that is uniformly spread through a region of space, that kind of entity yields repulsive gravity. If the very early universe, if it was filled with a uniform bath of this energy, we call it the inflaton field, the name doesn't matter, but if it was filled with that energy, it would have been subject to repulsive gravity. What does repulsive gravity do? Pushes everything apart, causes everything to rush outward. So the bang of the Big Bang may have been a spark of repulsive gravity operating with a tiny region of space that pushed everything apart.
One of the common misconceptions about Big Bang model is that it fully explains the origin of the universe. However, the Big Bang model does not describe how energy, time, and space were caused, but rather it describes the emergence of the present universe from an ultra-dense and high-temperature initial state. It is misleading to visualize the Big Bang.
But my question always is, right? He said the ultra dense original state, right? And that ultra dense original state had to have infinite mass. My question always is, how did all that mass come together to begin with before the Big Bang? That is always my question. And obviously it's not going to get answered, but...
by comparing its size to everyday objects. When the size of the universe at Big Bang is described, it refers to the size of the observable universe and not the entire universe. To better understand the universe at its earliest state and its subsequent evolution, cosmologists have come up with the chronology of the universe, which describes the history and future of the universe according to Big Bang cosmology. The first picosecond of cosmic time, which is 1 trillionth of a second, includes the Planck epoch, during which currently established laws of physics may not apply. Comes the emergence in stages of the 4 known fundamental forces: first gravitation, and later the electromagnetic, weak and strong interactions, and the expansion of space itself and supercooling of the still immensely hot universe due to cosmic inflation. Tiny ripples in the universe at this stage are believed to be the basis of large-scale structures that formed much later. If we were to look at the universe 1 second after the Big Bang, we would see a 10 billion degree sea of neutrons, protons, electrons, anti-electrons or positrons, photons, and neutrinos. At about 1 second, neutrinos decouple. These neutrinos form the cosmic neutrino background. If primordial black holes exist, they are also formed about 1 second of cosmic time. Composite subatomic particles emerge, including protons and neutrons, and from about 2 minutes, conditions are suitable for nucleosynthesis. Around 25% of the protons and all of the neutrons fuse into heavier elements, initially deuterium, which itself quickly fuses into mainly an isotope of helium. By 20 minutes, the universe is no longer hot enough for nuclear fusion, but far too hot for neutral atoms to exist or photons to travel far. It is therefore an opaque plasma. The recombination epoch begins at around 18,000 years, as electrons are combining with the helium nuclei. At around 47,000 years, as the universe cools, its behavior begins to be dominated by matter rather than radiation. At around 100,000 years, after the neutral helium atoms form, helium hydrate is the first molecule. Much later, hydrogen and helium hydride react to form molecular hydrogen, which is the fuel needed for the first stars. At about 370,000 years, neutral hydrogen atoms finish forming, and as a result, it also became transparent for the first time in our universe. The newly formed atoms, mainly hydrogen and helium with traces of lithium, quickly reach their lowest energy state by releasing photons, and these photons can still be detected today as the cosmic microwave background, or CMB. This is the oldest observation we currently have of the universe. While it is not known what could have preceded the hot dense state of the early universe, or how and why it originated, or even whether such questions are sensible, scientists have put forth numerous hypotheses and explanations.
It could be that the Big Bang was an interesting event, but not the first event in the totality of reality.
Right.
It could have been the first event that sparked the expansion of our part of space.
Right.
But it could be that there's a grander realm of space within which we sit as a small part, and that grander realm may have been there for a far longer period of time. It may have
not only that, but they always say that for every particle of matter, there's a particle of antimatter. So if you think about it, somewhere either like within our, not within our universe, but shifted into a different dimension, or outside of our universe, near our universe, but not touching, obviously, because they would cancel each other out. There's an antimatter universe. So there's the possibility that there could be an antimatter version of you, me, your house, this whole planet. Literally every single person that's alive right now, there's an antimatter version of them. And if that's possible, then it can't just be that because the Big Bang, supposedly, that's the theory, created a matter universe and an antimatter universe. So the question, even though it's hard to fathom, it's what's beyond the universe. And when they talk about the Big Bang, my mind automatically goes to beyond the universe, because if there's an antimatter universe, then things had to be created out beyond the universe. So I personally don't think that the universe is the limit of existence, if that makes sense.
Experienced its own Big Bangs, maybe a collection of Big Bangs that may extend infinitely far into the past. So it could be that the answer to the question of what happened before the Big Bang is a lot of other Big Bangs, or a lot of other quantum events that were taking place in a larger landscape of reality than we have direct access to.
Right.
The simplest models, in which Big Bang was caused by quantum fluctuations. The universe came into existence instantly, in our perspective, due to the absence of perceived time before the Big Bang. Models include the Hartle-Hawking no-boundary condition, in which the whole of space-time is finite. The Big Bang does not represent the limit of time, but without any singularity. In such case, the universe is self-sufficient. Brain cosmology models, in which inflation is due to the movement of brains in string theory. The pre-Big Bang model, the ekpyrotic model, in which the Big Bang is the result of a collision between brains. And the cyclic model, a variant of the ekpyrotic model, in which collisions occur periodically. In the latter model, the Big Bang was preceded by a big crunch, and the universe cycles from one process to the other.
The thing about the Big Crunch, though, like they've always talked about the Big Crunch, I personally don't feel like. So the Big Crunch is supposed to be that eventually the universe is going to stop slowing, it's going to stop expanding, and then at some point, eventually, gravity is going to wind up pulling everything back together, and it's almost going to go in the reverse of what it's going now, and eventually everything will come back together, and it's almost like this bouncing ball where it expands, pauses, contracts back together, and then repels again. But the problem is that even if you've been watching the videos with me, the last science video that we just saw, they talked about the fact that the universe is expanding, and not only is it expanding, but it's accelerating on top of that. So if expansion is accelerating, the Big Chill, which is another theory, is way more likely than the Big Crunch. The Big Chill is just saying that eventually the universe will expand to the point where nothing, protons, electrons, muons, won't be able to come together to create new structures, and everything will wind up just going cold. And the only thing that you'll be able to see even trillions of years down the line are the remnants of the galaxy, which is just red stars, and that's it. don't know if I did the
Eternal
greatest job
inflation
explaining
is the
it.
model in which universal inflation ends locally here and there in a random fashion, each end point leading to a bubble universe, expanding its own Big Bang. Proposals in these categories see the Big Bang as an event in either a much larger and older universe or in a multiverse. While we currently do not understand, or may very well never understand, how the universe spawned into existence, and whether questions like, what was there before the Big Bang, make any sense, scientists will nevertheless continue searching for answers.
Right.
Thanks for watching.
Yeah, man. That's crazy. Like that really is crazy though. When I forgot where I watched it when they talked about the fact that eventually trillions of years down the line, like let's say that somehow magically humans still exist, whether that's we exist in this physical form, because that's why I love science. Because one of my favorite movies, Interstellar, was talking the whole movie technically is about, it's not only about love, but it's about humans from the future that exist within 5 dimensions, not the 3 that we exist in now. So we evolved to exist outside of the physical form. So let's just say that humans stay in this physical form and we wind up living trillions of years down the line. The stars are going to look different. Basically, it's going to be a very much darker sky, because as we speak right now, galaxies are pulling away from each other, and literally the only stars a trillion years from now that you'll be able to see are the stars from this galaxy and Andromeda, because it's going to become Milkdromeda, because we're going to wind up combining, and maybe a few other satellite galaxies that orbit this galaxy. But all the other galaxies that we could see now in the future won't be able to see them at all. And humans that exist trillions of years down the line are basically going to be envious of us, because they won't be able to see the night sky that we see. I'm in New York City. All I see is clouds. I never get to see the stars. So it is what it is. But yeah, man, I love videos like this. I could watch these all day. If y'all want to see me react to more videos like this, like I said earlier in this video, please, all you have to do is just take 1 second and press the like button and the subscribe button. That'll help this channel out a lot. We're going to leave it there. My name is Reign. Catch you on the flip side. RCP salute. Wait for it. Dab on them.